When you're designing chiplets, you're going to have to connect them together in some fashion. And Baya has a solution. Could you tell us a little bit about what it is and how it works?
Absolutely. So in the big picture, when you're developing SoCs, and nowadays with these multi-chiplet systems that go into a package, you've got your accelerator cores, you're seeing a lot of AI accelerators, you've got your big CPU complexes, but you need all the logic to connect it all together to deal with, transport, your read and write commands, but nowadays, dealing with things like cache coherency, especially across multiple chiplets, and that's the kind of thing that we provide.
So there are some standards that are emerging like UCIe, but a lot of people are potentially wanting custom or want something right now. What types of things do you offer to make that job of designing easier?
So the big players right now, there's a BOW specification and there's a UCIe specification. And when it comes to chiplets, the industry is hungry for some sort of standardization so that we can realize this dream of a chiplet ecosystem, plug everything together. What we do is we provide packetization services that plug into our NoC that seamlessly connect to the UCIe PHY controller of your choice so that we see it as almost a bump in the wire as we're constructing this on-chip network that actually spans multiple chips.
Now, are there different features that you can put into that NoC or utilize within the NoC depending upon what your requirements are?
Oh, absolutely. So one of our hallmarks is extreme flexibility. We've taken the approach where we want a simulation first. So you're designing the system, you're thinking about your topology, you're thinking about the floor plan, you're simulating the traffic flows right up front, and then we take advantage of those simulations to construct all of this connectivity within the die and between dies across these die-to-die connections that we were talking about.
Now, if I'm designing a system, do I wind up with a very large, all-encompassing network on chip, or is it going to be connections between individual chiplets that I'm going to design the pieces on?
So the real answer is both, right? When you're looking at things like cache coherency, deadlock avoidance, you really have to take a global view of it, right? You can't afford to just design for one chiplet, plug it together, and hope that you don't run into trouble. But at the same time, each chiplet is its own tape-out, and when you're talking about multi-chiplet designs in a package, you want to be able to take these chiplets and arrange them in different ways. And what you've designed for might not be the limit of what you end up doing once you assemble these into bigger systems. So what we do is we give you things like global package level deadlock avoidance routines and everything else, but you still have the ability to have enough programmability so that in the future when you arrange these chiplets in different ways to build up your packaged product, that we still have that level of flexibility.
Now, do I have to essentially design both ends, chiplets on both sides, or does your network hook into other people's configurations?
So the way the industry is right now, honestly, is we don't see much of an ecosystem. So we have UCIe as sort of the base layer for interoperability, right? But there's a couple of competing standards for the higher level protocols on top of that. So for example, you might want to extend your NoC to support AXI on both sides. There are a couple of standard ways of doing that. They're not one. The way the system is right now, or the way the industry is right now, people tend to be co-designing them together. But it feels like we're very, very close to that point where you can really design two chips independent of each other, come along later on and make them work together. So that's very important in the standard space.
One of the challenges you have when you're dealing with something like this is how are you going to debug and support? Is part of the definition of your network something that's going to provide those kind of facilities?
Oh, absolutely. And that's absolutely key when you're bringing up these big, monstrous, complex systems, right? Is the ability to have visibility into what's going on. So I would say that we have three key features that enable this. We have a rich control and status register space. So you can come in and you can read and write things, you can change things, you can change the address map, you can control routes at runtime. We also have a rich set of performance monitors. So you can come in at any time and say, how many packets have I sent, et cetera, et cetera. And the way performance monitors work is you have flexibility at runtime about what you're monitoring. And then third is the trace and debug. Being able to say, I want to set a trigger to alert me as I'm in the lab debugging this when a given event happens. Maybe an access to a given address, maybe a transaction with certain characteristics, etc. So the ability to put all of these together and then really look at what's going on inside the chip is key to fast time to market.
Excellent. Well, thank you very much for filling us in on Baya's options in terms of making chiplets work.
This is my pleasure. Thank you very much, Bill.